Today I'm gonna show this coil of mine. I said in the previous video that I was going to make 3 videos on high-speed testing, but it's gonna be 4 since I was looking through my stuff and I found this coil I had laying around, which also perform pretty well at RPM just below 3000. So gonna do a test with it today. As usual, gonna do a 1 watt AC load, a 9 watt AC load. All these 9 light bulbs are in parallel. The RPM test, of course. Then I'm gonna do a 1.2 watt DC test, a 5 watt DC test, and of course filling up the big capacitor. Switching the system on. It is saying now 28.8, but when it level at this higher speed, it will be around 28.5 volt input unloaded at roughly around 1 amp. Gonna start it up. First speed. As in the previous video, I have written down the load test and the RPMs, because with this coil it also does take a while when it's loaded to reach its lowest RPM. So not to make this video very long and boring, I decided to write it down again. I will measure the RPM, but it will be a little higher than what is written here on the paper. Going over second speed. Oh yeah, by the way, this coil here is also an air core coil, or maybe you cannot call it an air core because it really doesn't have a core the way that I wound it. But this is performing pretty well. The output isn't that bad. I'm still using the 24 pole rotor. I am stepping up this coil's voltage because it's too low to drive these 230 volt AC lamps. Third speed and overdrive. There's the motor side going, the flywheel, and the test generator setup. Let me check the RPM. $24.50. Yeah. Give it some time. Unloaded RPM will be around 2970. But we're gonna start the testing the moment it reaches around 2950. Yeah, something like that. Gonna check the RPM again. 2800. So just a little bit more. Give you a shot of all the pulleys and belts. Yeah, I think we're there now. $2,948, 49.50. Yeah, we can start the testing. Gonna do the 1 volt AC load first. Remember, it was 2950 roughly. There's a 1 watt light bulb. With this load it will settle down around 2735 RPM. Let's see where it's at this moment. 2800. So it still needs to drop around 100 RPM. Let's give it a little bit of time. Check it one more time. 2775 and decreasing pretty fast. Wait for it. When doing this kind of test you have to be patient, very patient. $2,757 and slowly decreasing. Okay, 2,755. Look, leave it like that. Now I'm gonna do the 9-watt load. Yes. As you can see, the 9-watt load is on now. That's not very bright, but it is on. This will make the system stabilize around 2745 RPM, just a little bit higher than the 1-watt load. Let's see if that's correct. 2773, 72, so it is slowly decreasing. 71, 17. Okay, so that's also good. Now I'm gonna short the EC side, gonna short it before the transformer. So the transformer now is out of the picture completely. Gonna remove it, put it there. EC side shorted, and that should make the system settle around 2630 RPM, which is the lowest point, lowest RPM on the AC side when shorted. Let's check the RPM. 2648, 43 and decreasing. We're not gonna wait for it because it takes a while. Now I'm gonna do the 1.2 watt load on the DC side. I'm connected the 1.2 load now. Removing this light bulb over here. Connecting the AC output to the rectifier. In my previous video I forgot to mention the output on each state, so sorry about that. That kind of things happen. This is the 1.2 watt load. Output is 4.4 volt DC at say 170 milliamps. RPM should be 2644. When it's stable, let's check it. 2677, 76, decreasing, 75. But we're not gonna wait for it. Now I'm going for the 5 watt load. There you can see the 5 watt load. It is lit slightly, and that one is at 3.4 volt DC at 180 milliamps output, and the RPM of the 5 watt is the same as the from the 1.2 watt load, 2644. When it's stable, when it's stabilized, 2671, 70, 69 and decreasing. But we're not going to wait for it. Now I'm going to short the DC side. As you can see, it is shorted. Shorted, it's 200 milliamps. short, it should be the same as the EC short, which is 2630. Let's check it. 2695, sorry, 58, 59, 58 now, 57, and decreasing. It will stabilize at 2630. If you have seen my previous video, you can see there that when the coil was shorted, it was higher RPM than when it was loaded. So you see, different coils configuration give you different results. If you haven't seen this kind of results in your testing, then you haven't done enough testing. It's simple as that. Or you have to get far more creative with winding your coils. Check the RPM one more time. It is now shorted on the DC side. 200 milliamps shorted. Checking the RPM. 2649 now. 48, so it's still decreasing, and if it will stop at 2630. Now I'm going to fill up this large capacitor. Capacitor is empty. Little bit of spark there. This time the capacitor, when it's completely full and it's keeping its charge and it's being continuously filled by the coil, the RPM will be around 2750. In the previous video, the capacitor gave me the most load on the system. Now the capacitor gave me the less load on the system. The lesser load on the system, or whatever you want to call that. It is now at 12.5.6. Here you can see 13 volts at 100 milliamps. We're going to check the RPM. 2734, 35. It is climbing because the capacitor is getting fuller. I completely forgot to switch to this meter here, so you can see the drive side. When it was unloaded, it was 28.5 at 950 milliamps, and now it is just like a little bit above 1 amp, say maybe 100 milliamps more or 50. So the system is pulling, yeah, like 100 to 150 milliamps more when it's being max loaded. The capacitor is now at 15.3. The panel, the meters panel is saying 15.2. Here also 50.2. It's basically the same at 100 milliamps. Let's check that RPM one more time. 2756. I've written here 2750, so yeah, it's a little bit higher now, but it's a machine, so a few RPM more or less, it varies. It's more than normal. It's pretty stable now. Let's see, have I shown everything? Oh yeah. The unloaded RPM is 2970. When it's loaded max, in this case with this coil, it is when it is shorted, it is 2630. So when max loaded, the system has 340 RPM less. So in other words, this coil does perform pretty good. Maybe a few more hundreds RPM and it won't affect the system. But like I said, I don't like doing high RPM tests with wooden rotors. Here's the capacitor one more time, and the meter. Now I'm gonna go back to the gonna go back to the 9-watt AC load, which I always do, and gonna shut the system down and let it freewheel away, because this has no cogging effect either. Gonna put now the 9-watt load. Capacitor is now disconnected, as you can see. There is plenty of juice in the system, in the capacitor. The 9-watt load is lit, not as bright as before, but it's still lit. Let me give you a look of the system one more time. Yeah, there it is. Yes, side view, or a view from this side. Now I'm going to disconnect the complete system. No input, no input, and of course it is still freewheeling away or spinning away because there is no cogging effect. Give you a view in the dark. Is the capacitor slowly dying. There is 6.2 volt in the system here in the capacitor. I will be making one more video on high-speed coil, and that will be a video on this coil here, which what I think is the best one. It's an ugly one, I know, but the performance is pretty good. It does affect the system, but you will see in the other video in a few days time. Then I'm gonna choose one or two of these coils to try to improve, and then we'll take it from there. Hope you enjoyed this video, and thank you for watching.